Good morning, myself Krishna. Let's talk about uh, machine learning algorithm. So, in my previous video, I spoke about type of machine learning. So we have two types: supervised, unsupervised, and in supervised we have classification, regression. Unsupervised we have clustering and association. In today's video, we would be talking about the algorithm which we used to follow for for each models. So here for the classification, we use logistic, SVM, decision tree, KNN, random forest, Napier classifier. So when I get into the details about those, I won't be talking about all the algorithm, but I would be speaking whatever we are extensively using um, uh, nowadays. So logistic is very famous. SVM, you can see SVM, we can use in classification and regression both the places. Even random forest, you can see it is available in both the places. So it can you can use in classification and regression both. Decision tree, I'm not going to talk because here it's all about uh, one tree, and here you can have some set of tree. So this is widely used, not this one. So we will be talking random forest and clustering. We are going to talk k-mean clustering, hierarchical clustering, DB, scan. So I will be explaining k-mean clustering. Association a priori algorithm equal app growth. So before we get into algorithm, I thought of speaking about type of parameters that is important to know. So in machine learning, what all parameters we are dealing, what is important of the model parameter. So generally, model parameter, how you can define this model parameter. So these are internal parameters of machine learning that are learned from training data during training process. So just to explain here, let me open this one. So just think we have this linear data set, and for the linear uh, we have y is equal to mx plus c. This is the formula. So in the beginning, if you know what is machine learning, it's all about making prediction based on historical data set. So all we are going to do when we are training our model, we are finding this formula. Um, so just for now, you think the data set we are having, where um, we have we have followed linear approach, um, but this is not necessarily it can be non-linear. It's all depends what type of data set you are getting to train your model. So for the time being, just think this is the model. This is uh, the data set which I got. This is what I drawn here. And then what you can do, since you already splitted your data into training and test, so 80% you are using training and test data. So once your model is formed here by this formula, you can use this test data and see how this is going to fit. Okay, and you can calculate the accuracy. So by calculating accuracy, you will get to know like how much percent your model, I mean this equation, uh, is predicting correct value. So, like I said, this y is nothing but this value which is going to, we are going to define x is features. So, like if you remember, you have given data for diabetes patient. If we are to detect corona patient, and you can have some set of features and target. And target would be whether this patient is diabetes, yeah, heart patient, yeah, corona positive patient. So based on the input, you are predicting wide output. Okay. So here, what we are doing during training, we are we need to find, we need to um, get best fitment value for m. M is nothing but in mathematical term, people used to say slope. Yeah, you can see like these are two vector v1 v2. So this is m, like you can see the this is theta, we used to call the direction of the m. So in machine learning term, this M generally people are using W as a weight. I mean number of weights depends on number of input we received, and we need to find the best weight. And this is C is nothing but intercept या bias. So generally we need to find out best value for W and C so that our prediction can have higher accuracy. So this is all we are talking. This is all it says in the weight and bias. So we are doing, we are finding best fitment value for weight and bias so that our loss parameter should be minimum. For now, you just keep this note. Coming to hyperparameter, it's all about following a strategy. Like when you are going to train your model, how you are going to uh, train your model. I mean, there could be some random initial value, like we are when we believe there could be some starting point, right? So, like I just said, if this is just for now, if my um, my model is my data set is linear and we have uh, got this value 0.2 is the best fitment and c is equal to 5. If this is my best parameter, best fitment parameter, so to get this value, what we need to do, we need to start it from somewhere like w is equal to 5. Yeah, what we are going to get, I mean, uh, how uh, this l- loss function, what could be the loss function if w is equal to 5, what could be the loss function if w is equal to 6, what could be the loss function w is equal to 4. So here you can see the number of iteration, yeah, epochs, the number of time you are uh, following to train all your model. So all we are doing, we are going to converge at some point where this cost function should be minimum, and it depends the number of batches you are going to follow. But right now you don't need to do this many exercise because we have predefined library. And while using, if it didn't converge, you might be getting some warning like this converge, I mean it has not reached to this point. So concept wise, we have in the hyperparameter, we have three things: learning rate, number of epoch, and batch size. So like learning rate, you can see step by step you are checking uh, for reaching here. Yeah, from here also you can start. All you need to do to find uh, uh, minimum loss cost function. Actually, it will be loss function, and when you take average, it could be the cost function. And when we say gradient descent, this is also same thing which I talked just now. It is model optimization parameters. So it is about finding best fitment value for uh, for weight and bias. So, like, you need to first initialize, find the loss function. This is iterative approach. Uh, we are setting some random value, changing W value, and see the uh, predicted loss function. And at some point, you can see it has arrived minimum. We can't go um, we we can't uh, go go below 0.06, and this is the approach, the repetition and all. So this question most of the time, uh, they used to ask what is gradient descent. So just for your memory, this is model optimization parameter. It is trying to find weight and bias uh, s- uh, to to get your global minimum value. So this is learning rate. So what is key concept here? Like so far I was talking same thing. Uh, it is showing here like you can see this global minimum is very um, when learning rate you can see this step is very too small. This is too high. But here goal is we need to identify global minimum, whatever uh, number of iteration you are making, whatever number of epoch you are selecting, all uh, all you need to do, you need to converge at some point where your cost function is minimum. This is the goal here entire in the entire gradient descent. And in 3D, it will appears like this. Yeah, I mean, if your data set is scattered around all three dimensions, there how you can um, uh, find global minimum where your loss function should be minimum. So this formula we know cost function. Um, so loss function is equal to y barabar y is equal to mn mx plus c. And similarly, if you can, you have number of features, it will be like this. So this is your model, predicted value minus true value. So uh, and and slash number of value, it will be giving loss function, cost function. Now coming to bias variance trade-off. So what is bias variance trade-off? So while building machine learning model, it is important to take care overfitting and underfitting in the model. So what happening when you get your model, you need to keep balance of bias and variance so that you can reduce overfitting, yeah, underfitting. So what we call bias and what we call variance. So just think this is my data set. This is like once uh, this is my training data, right? Something like that. And this is the best fitment line for this is my model. Uh, so you can see the ideally this is true data, but this is your predicted data, right? So at this point, you can see there should be some vector value. That is just think 3, 4. This could be uh, your 2.75 to 4.5. So there should be some difference. So this is called bias, right? So here, when bias is higher, generally you don't see variance. Here you don't see any variance here, right? So this we call it as underfitting. Just think if I make this model where it is going to touch all the data point, right? So what will happen? This will be overfitting where there is no bias, but you can see variance. So this is uh, what they are saying concept of trade-off. It means to manage to manage this bias and variance in more appropriately so that you can adjust this overfitting underfitting. We can't say there won't be any underfitting, yeah, overfitting. It used to happen, depends upon your data set. But here you just need to find out best way to define your model so that you can have better accuracy. So this is the diagram. It shows like this is my model and this is actual value. So this is the bias and overfitting here. You can say it is going through all the data points. So, but here you can see in a variance, but no bias. So this is what underfitting, and you can take. So this is best. We need to always look for optimal balance. If you uh, go with overfitting, then also we can't say it is best model. If you go with an underfitting, that also we can't say it is best model. So you need to find out optimal balance and make sure we have a large set of data where we can train our model to get this optimal balance value. So for now, it's fine. I will be catching tomorrow with machine learning algorithm. Thank you. Bye bye.